Hello friends and welcome to our third lesson in the Lean Six Sigma. The main goal behind those videos is to help you to understand the measure tools used in the Lean Six Sigma and implementing it in your work responsibilities area, being capable to participate in improving the business performance in terms of quality, operational, and financial KPIs. In the last lesson, we discussed the histogram and the calculation of the standard deviation as a preparation for the lesson of today, the process capability. The importance of studying the process capability is summarized in the evaluation of our design processes to understand so far how they are effective, efficient, and being capable to achieve our business targets. Regardless, those processes are in healthcare, manufacturing, financial, education. Process capability can be measured since that we have measurable data. In the lesson of today, we will go through a quick definition about the process capability, the statistical measurement of the process capability with a working example. Don't go away.
The process capability is measuring the inherent ability of a process to deliver certain products or services within limits of specifications. The inherent variations are always existing in our processes and can be controlled. In the last lesson, we discussed the standard deviations, and we highlighted that a low or a high standard deviation will result a low and a high variation. The high variations, if exist, it is mainly because of special or what we call assignable causes existing in the process. Now, let's see the main statistical indices that measure the process performance and the process capability. The first one is known to be the potential capability. And from the formula, we can see in the nominator, the upper specification limit minus the lower specification limit, which is known to be the voice of the customer, because the specification limit are mainly defined by the customer. While in the denominator, we have 6 multiplied with the standard deviation within. And the standard deviation within is mainly related to the inner ranges of the samples that are collected from the same population. I repeat again, if we are collecting different samples for the sake of analysis from the same population, then you might find differences in the ranges of those samples. And calculation of the standard deviation within is done by getting the average ranges of those samples divided by the constant statistics D2, which can be found from the table of the range control charts in corresponding to the subgroup size or the sample size. The second statistics measure for measuring is the process capability is known to be the process capability index, the CPK. And the CPK is got by the minimum value out of the CPU and the CPL, where the CPU is the process capability for the upper limit, and it is calculated by the upper specification limit minus the mean divided by 3 multiplied with the standard deviation within. So if we refer to the example, which I like always to refer the car and the garage. So imagine that the side walls are the specification limits and the center of the garage is the mean of the data distribution. So the car is the data distribution. So if my standard deviation or the range of the data distribution or the width of the car is big that it is exceeding the distance of the entrance of the garage, definitely it will lead that you have a small accident in the rear side of the car. And that's exactly the same scenario in the process capability. So as bigger is the data distribution, the standard deviation is big, and the width of the data distribution is big, that will make the process capability more weak. And that's why it's very important that we focus all the time to reduce the standard deviation, so we have a thinner data distribution curve. So the potential capability is measuring how well the data fits in between the lower and specification limit. So imagine if you looked to the figure in front of us, that's the data distribution curve of a sample, and this is my lower specification limit and the upper specification limit. So the potential process capability is looking to the ratio between the range of the data distribution and the distance between the specification limit. While the process capability index is measuring how centered is the data distribution in between the both specification limit. Here you can see those are the possible outcomes of the CP and CPK. So you can see in the first scenario, which is considered the best one, as the target mean and the actual mean of the data distributions are aligned together. And that's why the CP equal the CPK equal to 2. And as we highlighted, here the range of the data distribution is half the distance between the lower specification limit and the upper specification limit. So that's why we will have a strong capable process which is equal to 2. In the second scenario, we can see a shift of the data distribution from the target mean, that the mean of the sample touch the upper specification limit. The range of the data distribution didn't change, so that's why the potential capability, the CPE, remained 2, while the CPK, the process capability index, became 0. And why 0? Simply because if we refer to the formula, you will see that the upper specification limit and the mu are located in one point, and then it will be equal to 0. The third scenario, if the actual mean of the data distribution shifted from the target mean and became in the center between the mean and the upper specification limit, then we will have the potential capability remaining 2 because the range didn't change, while the CPK became 1. Why? Because the CPK, as we highlighted, it's measuring the position, the central position of the data distribution in corresponding to the specification limit. So as you can see that the data distribution is just touching the specification limits between the upper specification and the mean, and that's why the CPK equal 1. In the fourth scenario, we have seen that the actual mean shifted totally outside the specification limit. And that's why here we have the potential capability remaining 2, while the CPK became -1. The process performance indices. And the process performance indices is mainly used to measure the overall performance. And it's usually used when we set up and we started to an initial setup for the process. We need to make sure that we reach to a stability in the performance. So at the time that we have a stability in the performance, we always refer to the process capability. So again, I repeat that point, that the process performance indices are mainly used when we start a new setup of the process, but at the time that we reach a stability in the performance, we refer always to the capability process indices. The formula of the potential performance index and the process performance index are almost the same of the process capability indices. The only difference is the standard deviation overall. And here, the standard deviation is taking the standard deviation of the whole data, and it's calculated as per the formula, the square root of the sum of the data points in the samples, all the data points, minus the x double bar to the power of 2, divided by the degree of the freedom, which is the sample size minus 1. It's important to know that if we remark in any of our exercises a significant difference between the PPK and the CPK, that it will be an indication of a non-stable and out of control process. And that's why it is very important that before that we start to calculate the process capability, to make sure that my process is stable, under control, and has a normal distribution curve. Let's have a work example so we can better understand the importance of the process capability. A factory of fiberglass pipes received several complaints about difficulties in installing the couplings in the site work. The QA department considers those complaints as high risk and has a concern about the variations in the pipe's diameters, which might lead to other consequences after running the project. The target pipe diameter should be 2.25 meters and has a tolerance of plus or minus 0.15. Now, if we look to that project, imagine that I deliver to the site wrong diameter pipes. What could be the consequences? Number one, imagine if they install the pipe by force, then there will be higher risk consequences represented that it might happen cracks in the pipes, and later on explosion due to that the pipes will not be capable to maintain the high internal pressure. And even we can refer to the cost of the logistic cost to deliver, to returning back the pipes, the loss of the materials, the cost of the poor quality. All of those parameters will be mainly related to our process capability. So in this case, the QA department has to start with the containment actions. So we know what are the priority actions that we will do. In this case, the QA department will to stop the delivery to the site work and will check all the manufacturing process inside the factory. To do that, they decided to have a data collection plan in 13 days, where they will start to measure the diameters of 4 pipes each day. So we have 13 subgroup, and each subgroup is divided to 4 pipes. So the sample size is 4. As we can see here, those are the data collected, and we plotted the range of each subgroup with the X bar of each subgroup. And then at the end here, we have the average range of the samples plus the X double bar. Now, if we look to the range chart where we collected for the 13 samples, we can see that there are high variations in between the samples in the ranges, which is giving us an impression that there is an assignable cause that led to have these variations. And it is a must that we stop the machine and see what is the problem leading to those variations. Even if we refer now to the potential capability and the potential performance, if we look to the potential capability, it's 0.2. and even the CPK, the process capability index, is 0.16, which is a big failure. So either that there is a problem in the setup of the machine, that probably this machine has just started up after the setting of the machine, or there is a major failure in the machine that needs an immediate stop for the production line and check the problems. Now, if we plot all the data, those data we collected into a histogram, and plotting the lower specification limit, the upper specification limit, and the target mean, so we can better understand the process capability. So the target mean diameter is 2.25, and the lower specification limit is 2.1 meter, and the upper specification limit is 2.4. From the histogram, we can see a high portion of the data collected are exceeding the specification limits. And that's why we can see that the process capability is not capable at all to deliver the pipes with the specification. So imagine if we continue to produce the pipes and we have this type of process capability, definitely the cost of poor quality will be very huge. As a conclusion, either the potential and the process capability are very weak and not capable to achieve the targets, which can be an indication of a major failure had occurred in the machine. The machine current condition is totally not capable to maintain the customer specification, and it is a must to stop the machine to check the following. Number one is the mechanical setup for the required diameter. This type of machine is process manufacturing, and every time there is it produces a different diameters, there is a need to change the structure design of the machine. The feeders and chemicals pumps calibration, the pumps, the chemical pumps, the nozzles, all of those things should be well checked to ensure that they are calibrated and feeding as per the technical specification. It might be quite possible a PLC malfunction or a problem, or whatever, something wrong happened in the PLC. And even it will be a good idea to review the machine operation quality procedures and the skills of the operators. Now imagine if I maintained those improvement actions and I started immediately to check the machine and solve the calibration issues or the PLC, and then I recollected again samples for the pipes for 13 days. Now let's see how the data distribution will look like. From the data distribution, we can see now that the diameters are very close from each others, and it seems even in between the specification limits. And that's clear how the potential capability increased now to 1.4, and the process capability in the index become 1.36, which is a strong capable process. Now, if we look again to the histogram or the process capability chart after solving the issues of the machine, we can see how the safety distance between the specification limit and the distribution curve is much bigger compared with the first scenario. And now we can see the center of the data distribution even is very close from the target mean, which is an indication of an improvement in the quality process of the manufacturing, which transferred the weak capability to a very strong process capability with a high confidence, as the CP is exceeding the 1.33 or equal to the 1.4. So you can see now the importance of measuring the process capability with the example of the manufacturing process of the fiberglass pipes. I hope within those few minutes that I could explain the process capability with a working example. I thank you so much for your good listening and watching. Thank you.